In the next series of videos, we'll be looking at implicit differentiation. We'll start off with this particular problem here. And the thing to keep in mind here is when you use implicit differentiation, you simply take the derivative term by term, assume y is a function of x, and you use regular formulas. If it's a quotient, use the quotient rule, product, use the product rule, and so forth. And normally when you have these types of problems, you're expected to have something like y is equal to some function, some expression. Could have trig functions, log functions, polynomials, anything mixed, and you find the derivative y prime. And I'm using y prime as a short notation for dy over dx, or it could be f of x, could be a polynomial on the right side, or a mix of different types of functions. Take the derivative. But the main thing here is to realize that if you have y prime equals to dy over dx, then when you take the derivative of, say, y to some power n with respect to x, use the general power rule, n times the coefficient, subtract 1, and then you always take the derivative of y. That's using the chain rule. So in this particular one, this one's given implicitly. And generally when you think about implicit situation, generally the expression is not solved for y. Now we could solve this one for y by taking the minus 2y to the third to the right, everything else, the 2 over to the left, take the cube root of both sides and use regular differentiation. But a lot of times you can't do that. So it's more difficult. You could have, say, a 4y in front of this, next to this 4yx, and you have to use the product rule there. But here basically we go term by term. So take the derivative of x squared, we get 2x. Take the derivative of minus 2 y to the third, again assuming y is a function of x. So 3 times minus 2, the general power rule, gives you minus 6. Subtract 1 from the 3, you get 2. And then take the derivative of y. That's going to be dy over dx. I'm going to use the short notation here, y prime. Derivative 4x, that's regular derivative there, is 4. And the derivative of 2 on the right, a constant, that's 0. Now depending on your situation, you could have several expressions with y primes. So you simply isolate those terms so you can solve for y prime. In this case we only have one. So we'll do it this way. Got 2x plus 4. And I want to isolate the y prime, so I take the term that has the y prime right here, add it to both sides, or just take it over, changes the sign. This will be 6 y squared y prime. Then we want to solve, so we isolate, divide both sides by 6y squared. This divided by 6y squared. And then this divides out. I've isolated the derivative of y, or y prime. So y prime is equal to, then in this one right here, I could factor out the 2 in the numerator. Give me 2x plus 2. And of course the denominator, 6, has a factor of 2. 2's divide out. So the derivative of y with respect to x, denoted here by y prime, is going to be x plus 2 over 3y squared. So it's pretty much the same formulas that you use for regular functions, except in implicit differentiation, you go term by term. You could have a y squared, a y to the third. Just make sure you use the chain rule there when you compute the derivative of anything that has a y to power. In this case we get y prime equal to x plus 2 over 3y squared. More to come. Thanks for watching. We'll see you next time.